Okay, let us discuss the next problem. So this is problem number 2.44. This is a quite good problem. This says demonstrate that the process in which work performed by the ideal gas is proportional to corresponding increment of its internal energy. So this question says work performed. So we have a process in which work performed is proportional to change in internal energy, or you basically in this case it says increment in internal energy. If you are performing work on the gas, internal energy will increase. So work performed is proportional to change in internal energy. So this means dW, that is the work performed, is proportional to delta U, or I can write dW is basically K times du, where K is the proportionality constant. The question says demonstrate that the process in which the work performed by ideal gas is proportional to corresponding increment of its internal energy is described by the equation PVN is equals to constant. So equation for this process I have to find out. So equation for such process will be given by PV to the power n is equals to constant. So let us try to demonstrate this one, in which work performed is proportional to change in internal energy. Work performed is PdV and internal energy is NCV dt. So we will have NCV dt. Are you getting? Now I have to find equation of process. This is one, and I also have PV is equals to nRT. This is the second equation, and I can also use dQ is equals to du plus dW if we need. So let us find, I want to do integration. So how we will proceed? This side we have dV. I want only in two variable. So if I write P I can write nRT by V. So let us put P is equals to nRT by V. So from 1 I can write P is equals to nothing but nRT by V. dV is equals to K times N into CV so number of mole goes out this side and this side. So I will have dV this side by V is equals to this side we will have K times CV divided by R dt by T. Now these all terms are constant. K is a constant, CV is a constant, R is a gas constant. So this is a constant. So let us put this constant as another constant n dash, or you can say K dash. So let us put this constant as n dash. So this is a constant. Let us put this constant as a new constant n dash. So you will have dV by V. This is equals to n dash dt by T. Now if I integrate both sides, I will have ln V. This is equal to n dash ln T. So if I take this side, what we will have plus some constant of integration C, and constant of integration can be written in terms of ln also. So ln V minus n dash ln T is equal to some constant of integration, and this constant, let us say C. So this becomes ln V divided by T to the power n dash, because this goes to the power, so we will have T to the power n dash, and then ln A by B is equals to some constant C. Now this constant can be further written in new constant as a form of ln. So this constant can also be written as ln C1, because C1 is a constant, C is a constant. So from here I can write b by t raised to the power n dash is equals to, because this is ln, this is ln, so I will have c1. Are you getting or not? So this we are getting. Now I want my equation in terms of PV to the power n. So you see we have to prove PV to the power n is equals to constant. So this means I have to eliminate temperature. So there should be no temperature. So let us try to eliminate temperature using ideal gas equation. So if we apply ideal gas equation, what we will have, PV is equals to nRT. So we will have PV is equals to nRT. I want to eliminate temperature, so temperature will be PV by nR. Are you getting? Let us plug the value of temperature in this equation. So we will have V by T, T is PV by nR to the power n dash is equals to some constant C1. Now if we do some more massaging of this equation, so if I take this that side, so V is equals to C1 P to the power n dash V to the power n dash. Let us put n dash r dash this side. So we will have n dash r dash this side, because this will go up. Nr to the power n dash. Nr. So let us rub here. Let us put here itself Nr to the power n dash. Are you getting? Now this V, so if I put this side, so we will have Nr to the power n dash is equals to P to the power n dash V to the power n dash minus 1, and this divided by C1. Now this is a constant. So let us put this new constant, some constant C2. So this is the total is a constant. Let us put this constant C2. This is equals to P to the power n dash V to the power n dash minus 1. Now I can write again, if I take both side 1 nth root, so if I take 1 by n this side, 1 by n dash this side also. So what I will have C2 raised to the power 1 by n dash. This is P and this is V n dash minus 1 divided by n dash I will have. Are you getting or not? Now this is a constant, this is a constant, so this will be another constant. So let us call all this constant is n. So I can say PV to the power n. This is a constant where n is equals to n dash minus 1 by n dash. Are you getting? Now this is a constant, so let us write this is a constant. So my equation will be PVN is equals to constant. So you see, this is important result. If you have a gas that follow ideal law, and also if the work done performed is directly proportional to internal energy, in that case equation of the process is given by PVN is equals to constant, where n is a constant that depends upon the process. You can change the value of n. So now you see in this question, still we have some mathematics. You have been given the work done, the work performed on the gas is directly proportional to change in internal energy. And that is very true. If you do some work, some of the amount of work will change the internal energy. So if you work more, internal energy will increase more. So work performed is directly proportional to internal energy. And then you apply ideal gas law. And then simply integrate. You will get this PVN is equals to constant. So a process in which internal energy is proportional to work done, change in internal energy is proportional to work done. In that process, you have equation PVN is equals to constant. So process will be guided by the equation PVN is equals to constant. You have a special case, adiabatic process in which PV gamma is equals to constant. In that case, the value of n becomes gamma, that is Cp by Cv. Are you getting? We'll discuss the next problem.